Hello. In earlier two lectures on projectile motion, we solved problems based on equation of path. Now in this lecture, we are going to solve problems using equations of motion. Now watch here, a projectile is fired with initial velocity v0 at an angle theta 0 with horizontal, and of course it moves along a parabolic path and it strikes ground again. Now in a problem on projectile motion, what you know is it is a free motion under gravity, that is motion is fully governed by a single force, and that is gravitational force. And whatever asked about geometry of the motion, that is position, velocity, acceleration, time, we should use a procedure of analysis. What is that? Choose origin where projectile motion starts, write coordinates of points known or given in the path. If motion starts and ends at the same level, then check whether range and time of flight formula can be used. So in this case, motion starts and ends at the same level, so range or time of flight you can find out in this case using these two formulae. So if motion starts and ends at the same level, use these two formulae. Then check whether equation of path can be used. If given and asked this information is amongst these four parameters, then we use equation of path. This is equation of path, y equal to tan theta 0 x minus g divided by 2 v0 squared cos squared theta 0 into x squared. So remember, when xy coordinates and initial velocity, if that's all involved in a problem, then you use equation of path. And when equation of path is not sufficient, then we use equations of motion. For example, at t equal to t1, v1 is velocity of the particle magnitude and theta 1 is direction of the motion or angle of velocity with horizontal. Suppose you are asked to find in which direction the projectile must be moving at t equal to 5 seconds. You will not able to answer using equation of path. Or what is the speed or velocity of the particle at t equal to 3 seconds? You will not able to answer using this equation, because nowhere time is involved here. If you are asked at what time projectile is 20 meters above the ground, again that time you will not able to find out using equation of path. So equation of path, as I told you, if initial velocity and coordinates of points, and that's all involved in a problem, that is given and asked, are amongst these four parameters, in that case only you use equation of path. And equation of path is not sufficient to solve problem, right? Horizontal and vertical equations of motion. So how to write horizontal vertical equations of motion? Projectile motion is combination of horizontal and vertical motion. When particle moves freely into the air, its acceleration is due to gravitational force acting on the body. So its motion is fully governed by this single force, gravitational force, and therefore it has acceleration g in downward direction. So we know that horizontal component of this acceleration is 0 and vertical component is g, but in downward direction. It is downward direction, that's why negative sign. X 0. So Vx is constant, V0 cos theta 0 is constant, and x is equal to V0 cos theta 0 into t plus x0. x0 is initial position which is at origin, that means x0 is 0. So we need not worry about that x0. So these are equations of motion in horizontal direction. Ax is horizontal acceleration, that is 0, Vx is horizontal velocity, and that is horizontal component of initial velocity, v0 cos theta 0, and x is equal to v0 cos theta 0 into t. Similarly here, ay is minus g, ay is vertical acceleration. So vy, it is vertical velocity, it is v0 sin theta 0 minus gt. This is initial vertical velocity. So v is equal to u plus at, and what is a? Minus g. So we have simply replaced a by minus g and u by v0 sin theta 0, that is initial vertical velocity. Similarly, y is equal to v0 sin theta 0 t minus g by 2 t squared plus initial y coordinate, which is 0 in this case. So, acceleration constant v is equal to u plus at, x is equal to ut plus half at squared. Very standard equations of motion. Only thing is, these are all vertical components. Here also acceleration 0. V is u plus at, of course, here also. But what is a here? 0. That at term is not involved here because acceleration is 0. And what is u? Initial horizontal velocity, that is horizontal component of initial velocity. Similarly, x is equal to ut plus half at squared. That half at squared part is not involved here because acceleration is 0. So, horizontal motion is uniform velocity motion, vertical motion is uniform acceleration motion. So, these are the 4 equations we are going to use to solve problems. Remember, it is not a very long procedure. It's simple. If motion starts and ends at the same level, use these 2 equations. If x, y, v0 and theta 0 given and asked are amongst these variables, use equation of path. And now what I am telling you, listen. If time is involved in problem or anything other than this asked in the problem, you should use equations of motion, that is these equations of motion. Using equations of motion, whatever asked in the problem on projectile motion, you will be able to answer without any difficulty. Now, how to use equations of motion to solve problems. Now, during the motion, which are the variables involved in the motion? Variables. Is acceleration is a varying quantity here? No, acceleration is constant. So, at each and every instant, at each and every position, acceleration is g downwards. It is uniform acceleration motion. So, acceleration is not varying. Throughout the motion, horizontal acceleration is 0, vertical acceleration is minus g. Vx, is it variable? No. Horizontal acceleration is 0. So, horizontal velocity Vx is a constant. So, Vx is constant. X coordinate changes continuously. So, x is variable quantity. Y coordinate also changes during the motion. Y is variable. Vy also changes with time t. So, Vy is varying quantity, time t is varying quantity. So, these are the 4 variables involved. X coordinate continuously changes, y coordinate changes, time instant changes, Vy, vertical velocity continuously changes. But there are 2 more variables involved. Which are those 2? Try to understand. V is magnitude of velocity at any instant. So, magnitude of velocity is root Vx squared plus Vy squared. And theta is angle of velocity with horizontal, and that is tan inverse Vy by Vx. So, V is root Vx squared plus Vy squared. Vx is constant, but Vy is not. And therefore, V, magnitude of velocity, is a variable quantity here. Then, direction of velocity, direction of motion, direction of velocity means direction of motion. Direction of motion continuously changes, that is angle theta made by velocity with horizontal. How you find the theta? Tan theta is equal to Vy by Vx. So, Vx is constant but Vy is not, and therefore theta continuously changes. So, these are the 6 variables involved in study of motion of projectile. X and y coordinates, time is variable, Vy, V and theta. What is theta? It is angle made by velocity with horizontal. Read this problem. A shot is fired from a gun from top of a hill 125 meters high with velocity 240 meters per second at an angle of elevation 30 degrees. The shot strikes ground at point B. Find horizontal range, time of flight, velocity with which projectile strikes the ground, and maximum height reached by the projectile. So, let's visualize the motion. Draw diagram. Height of the hill is given. Height is measured from ground. So, there is ground involved. Then, height of the hill is given 125 meters. At top of the hill, shot is fired with velocity 240 meters per second. Of course, it moves along a projectile path and strikes ground at point B. So this is the situation involved. Now let's follow the procedure. Choose origin where projectile motion starts. So origin. Write coordinates of points known or given in the path. So let's write coordinates of point B. XB is x coordinate of point B, that is horizontal distance from origin, horizontal distance from the point where motion starts, that is x coordinate XB. And what is y coordinate of point B? It's below origin, so minus 125. Then if motion starts and ends at the same level, of course not, so forget that third step. Then check whether equation of path can be used. If given and asked are amongst these four, then we should use equation of path. But of course not. You are asked to find a time of flight. You are asked to find velocity at point B, and that's not all involved in this. So many things are asked and you will not able to answer using equation of path. So do not use equation of path here. So what finally? We should write equations of motion. Remember now what I am telling you. If time is involved in a problem, time given, time asked, then use horizontal vertical equations of motion and not equation of path. So let's write equations of motion. Horizontal and vertical equations of motion. So horizontal motion, vertical motion. Horizontal acceleration 0, vertical acceleration is minus g. In free motion under gravity, acceleration is minus g and there is no horizontal acceleration. Vx is v0 cos theta 0 and x is v0 cos theta 0 into t. Vy is v0 sin theta 0 minus gt and y is equal to v0 sin theta 0 t minus g by 2 t squared. So these are standard equations of motion. These are horizontal vertical equations of motion. Ax and ay you need not mention, it is understood. So these are basically four equations we are going to use to solve this problem. So use equations of motion, use horizontal vertical equations of motion means use these four equations. Now V0 is 240 and theta 0 is 30. So simply put these values here and write the proper equations for this problem. So Vx is V0 cos theta 0, 240 cos 30, that is 207.85 meters per second. So x is equal to 207.85 into t. Vy, V0 sin theta 0, it is 240 sin 30, 120 minus 9.8 t. I have substituted value of g as 9.8. And y is equal to V0 sin theta 0 t minus g by 2 t squared. So 120 t minus 4.9 t squared. So these are equations of motion for this problem. And now you are ready to answer the question. Now how to use equations of motion? Do you remember? Out of those 6 variables, which are the 6 variables? X, y, vy, t. These are the 4 variables appear in equations of motion. And the other 2 variables are speed, that is magnitude of velocity, and direction of velocity. So total 6 variables. So to use horizontal vertical equations of motion, which is that variable whose value at particular instant is given, check it and use that in equations of motion. For example, here, try to understand. Projectile starts at O and strikes ground at point B. You are asked horizontal range, that is horizontal distance of point where motion ends from the point where motion starts. Nothing but x coordinate of point B you want to know. You want to know x coordinate of point B. Okay. Time of flight. Now motion starts at t equal to 0 and ends. So at which time, what is that time at which motion ends? That is time at point B you want to know. That is time of flight. What else is asked? Velocity with which the projectile strikes the ground. So you want to know velocity. Velocity is vector quantity. So you should find magnitude of velocity and angle of velocity with horizontal. That is what is asked in the problem. Velocity with which projectile strikes ground. and maximum height reached by the projectile, that is this position you are asked. Okay, but now let's focus here. At point B, you want to know time, you want to know velocity, you want to know direction of velocity, you want to know x coordinate, then which is that variable whose value is known at point B? So y coordinate. So this information, y is equal to minus 125 at B, going to help you to find all other instantaneous values of the variables. So simple. When the projectile hits the ground, that is at point B, y coordinate is minus 125. Now which is that equation of motion for y? Equation 4. So put it in equation 4. Y is minus 125. It is a quadratic equation. Get two values of t. Remember, time measurement starts from t equal to 0 onwards, and therefore there is nothing like negative time. So we have found out the answer. At point B, y is minus 125. At point B, t is 25.49 seconds. So we have found out TB, that is nothing but time of light. Okay. You also want to know horizontal range. Horizontal range nothing but x coordinate of point B. So to find x coordinate of point B, you should know time at point B. Do you know time at point B? Yes, now we have found out. So put this in equation 2. So you have found out xb. That is nothing but horizontal range. So we have found out horizontal range, we have found out time of light. Now, what is velocity at point B? Remember, it is projectile motion. It is horizontal and vertical motion simultaneously. So to find velocity, you should find horizontal and vertical velocity. You want to know velocity at point B. So find horizontal and vertical velocity at point B. So equation 1 and equation 3, that gives you horizontal and vertical velocity. But we want to know horizontal vertical velocity at this time, 25.49 seconds. So from equations 1 and equation 3, Vx is 207.85 meters per second rightwards. It's horizontal motion. Positive answer. Now listen, Vx is constant. It does not change with time t. Vx is not function of time t. Means at all instants during the motion, Vx is 207.85 meters per second rightwards. And from equation 3, Vy you will able to find if you know time at point B. So put 25.49 seconds and Vy is minus 129.8, that is 129.8 meters per second downwards. Now once you know Vx and Vy, you will able to find magnitude of velocity root Vx squared plus Vy squared and angle of velocity with horizontal, that is this theta b, tan inverse Vy by Vx. Tan inverse Vy by Vx. Or in your calculator, there is a pole function. In your scientific calculator, you will find that there is a pole function. Use it and get V, magnitude of velocity at point B, and angle of velocity with horizontal. But this is not enough. Correct direction you should show in the answer. It is rightwards downwards. So combined direction, it is rightwards downwards. So this is that direction of velocity, rightwards downwards. So velocity of projectile when it strikes the ground, we have found out. What else is asked in the problem? Maximum height reached by the projectile. Now listen, y is function of time t. You want to know maximum height, that is a y coordinate of this highest point we will have to find out. So when y is function of time t, then when y is maximum, dy by dt is 0. And what is dy by dt? Vertical velocity Vy. So at y max, Vy is 0. So use this condition in equation 3 and you have found out t. So this is that time when particle is at y max. That means at this time, whatever is that y coordinate is maximum. So this is that y max. And this maximum y coordinate you will get putting t in equation 4. At this t, whatever is y coordinate, that is maximum y. But most important thing is y is y coordinate and not height. Coordinates are measured from origin. So this distance now you will get. And this particle reaches maximum height at t equal to 12.4. So put in equation 4 and you have found out y max 734.7 meters. But this is not the answer. Coordinates are measured from origin, but height is to be measured from ground. So you should add that 125 meters and write the answer. So h max is equal to 859.7 meters. This is the maximum height reached by the projectile, 125 plus y max. So this is how we have solved the problem. Now listen, y max, that is y coordinate of highest point on the parabolic path of the projectile. Y coordinate of highest point on the path of the projectile. That you can find out using this formula also. In very first lecture I have given you this formula. So you can use this formula, that is put V0 is equal to 240, theta 0 is equal to 30, G as 9.8 and you will get y max value same 734.7. And then adding 125 you can write final answer. So there are two ways to find y max. If you are using equations of motion, horizontal vertical equations of motion, then put Vy equal to 0, you will get time t and put that time t in equation 4 for y max, or use this formula. Don't forget height is measured from ground. Read this problem. A shot is fired from a gun from top of a building 150 meters high with velocity 250 meters per second at an angle of elevation 40 degrees. Find the time at which the projectile is moving at an angle 20 degrees upwards and the time at which the projectile is moving at an angle 20 degrees downwards. First of all, remember here time involved that suggested us to use equations of motion. In this problem, we are going to write horizontal vertical equations of motion. Simple. But let's visualize the situation. Height of the building is given. Height given, ground is involved there. Height of the building is 150 meters. And from top of building, at an angle 40 degrees, 250 meters per second, a shot is fired. So that shot strikes somewhere to the ground. Let that point be B. Now let's follow the procedure. Choose origin where motion starts, write coordinates of points given in the path, known in the path. Then, if motion starts and ends at the same level, check whether range and time of light formula can be used. So of course not. Check whether equation of path can be used. No, time is involved here. So we should write equations of motion. So this is how we have taken decision of using equations of motion. Listen, procedure of analysis keeps you on the right track and fluently you arrive at final answer. So let's write equations of motion. Horizontal motion, vertical motion. Ax 0, Ay minus 9.8. It is always true for free motion under gravity, so that you need not write. So Vx is V0 cos theta 0. X is V0 cos theta 0 into t. Vy is V0 sin theta 0 gt. Y is V0 sin theta 0 t minus g by 2 t squared. These are horizontal vertical equations of motion. As I said, V is equal to u plus at, x is equal to ut plus half at squared. Standard equation. So only thing is here a we have replaced by g. This is vertical velocity, this is initial vertical velocity. Similarly here also v is equal to u plus at. That at part is not involved here because horizontal motion acceleration is 0. Now V0 and theta 0 are known, so corresponding values you are going to put here so that you will get these 4 equations. Equation 1, equation 2, equation 3, equation 4 in this way. So Vx is 191.5. What is 191.5? 250 cos 40. 191.5 t. It is x coordinate, so unit is meter. This is velocity, unit is meters per second. Vy 160.7 minus 9.8 t meters per second, and y 160.7 t minus 4.9 t squared. Y is equal to ut plus half at squared. So these are standard equations of motion, and now you will able to answer the question. What is asked in the problem? The time at which the projectile is moving at an angle 20 degrees and the time at which the projectile is moving at an angle 20 degrees downwards. Now you know that initial, when it is projected, that is at t equal to 0, theta 0, angle of velocity is 40 degrees. But during the motion, angle of velocity continuously changes. Direction of motion means direction of velocity. What is asked in the problem? Listen. The time at which projectile is moving at an angle 20 degrees upwards. So this is the position where we want to know time. Also the time at which projectile is moving at an angle 20 degrees downwards. So we want to know time at this position also. There are 6 variables I have told you in projectile motion. X, Y, Vy, t, and which are the other 2 variables? Magnitude of velocity and angle of velocity. Out of these 6 variables, what is given in the problem? Angle of velocity. Theta v, direction of velocity. Theta v is given. And that is what going to help you to solve the problem. Tan theta v, direction of velocity. How we find direction of velocity? Vy by Vx. Tan theta v is equal to Vy by Vx. So in first case, angle of velocity theta v is 20 degrees. It's given 20 degrees. So put theta v as 20 degrees. Vy, what is Vy? 160.7 minus 9.8 t. And what is Vx? 191.5. And you have found out the answer. So t is equal to 9.286 seconds. So when projectile is moving at an angle 20 degrees upwards, what is the time? 9.28 seconds. The time at which projectile is moving at an angle 20 degrees downwards. So put theta v as minus 20. Vy 160.7 minus 9.8 t. You cannot use this value of t because this is the different instant here. And Vx is 191.5. And you have found out the answer. Read this problem. A ball thrown from top of a building 150 meters high with velocity 35 meters per second at an angle of elevation 50 degrees. Find the time taken by the ball to cover the distance between 2 points in its path 175 meter above the ground. Again, time involved. We are going to use horizontal vertical equations of motion. Simple, straightforward problem. Just visualize. Visualize the situation or this motion. So from building 150 meters high, a ball is thrown at an angle 50 degrees and velocity 35 meters per second. So that ball moves along a parabolic path. It strikes ground, say at point B. So we are following procedure. So I have chosen origin where motion starts. I have written coordinates of point B. Then if motion starts and ends at the same, no, forget range and time of flight formula. Then are you going to use equation of path? No, time is involved. So don't use equation of path. Then what? Equations of motion. So write equations of motion. So these are the 4 equations of motion we are going to use. Here V0 35 and theta 0 is 50. So let's put the values. So this is how you will get the 4 equations of motion. V0 cos theta 0 is 22.5. V0 cos theta 0 into t here. And here V0 sin theta 0 minus gt. So this is how we have found out the 4 equations of motion. So this is very straightforward problem. And after writing equations of motion, out of 6 variables, which is that variable value is known? Let's check it. Find the time taken by the ball to cover the distance. You want to know time, but for what? To cover the distance between the 2 points in its path. So in its path there are 2 points 175 meters above the ground. So on this path, on this curve, there are 2 points which are 175 meters above the ground. So from these two, between these 2 points, how much time this projectile takes? That is what is to be found out. Time taken by the projectile from this first point to the second point. Both points are 175 meters above the ground. So height given means y coordinate given. But remember, height is measured from ground and y coordinate is measured from origin. So this is y coordinate. So when particle or projectile is 175 meters above the ground, its y coordinate is 25 meters. So this information, so just put y here and you have found out the answers. So out of 6 variables, which is that variable whose instantaneous value is known? Use it in equations of motion. So when the particle is 175 meters above the ground, y is 25 meters. Put in equation 4. So you got a quadratic equation. Solve it and you have found out these two answers. Both are positive. Do you mean that particle is at height 175 meters twice? Yes. It is parabolic path. So twice the particle is at the same height. So visualize. At t equal to 0, motion starts. At t equal to 1.192, particle is at this first position, which is 175 meters above the ground. And at t equal to 4.279, particle is in the second position, which is 175 meters above the ground. So listen, particle is here at t equal to 1 second and particle is here at t equal to 4 seconds. So how much time it takes from first position to second position? 4 minus 1, that is 3 seconds. Of course, we are going to write proper answer. So time taken by the projectile to cover distance between the given 2 points, t dash is equal to, t dash is time taken between these 2 points. 4.279 minus 1.192, and this is the time taken by the projectile between these 2 points, or to cover the distance between the 2 points. Okay, read this problem. It is observed that a skier leaves the ramp at point A and hits the ground at point B in 5 seconds. Refer the figure. So figure is given in this problem. Determine his initial speed, that is u, and angle of projection alpha. So this alpha. So here V0 is labeled as u, numerical value is not given, and theta 0 is labeled as alpha, numerical value not given. In fact, you are asked to find u and alpha. If time is involved, we use equations of motion. Now check here. Time is involved. Draw neat line diagram. Why? I'll tell you. This is the velocity. Magnitude is u, angle with horizontal is alpha. The skier moves along a parabolic path, strikes ground at point B at t equal to 5 seconds. It's all information given. This length is 100 meter. All dimensions are very important. Now listen, earlier while solving problems on statics, how many times I have told you that if distance is given along an inclined line, you should show in the diagram corresponding horizontal vertical distances using right angle triangle geometry. So this is how I have constructed a right angle triangle. What information you have in this triangle? So it is right angle triangle, means this angle is 90 degrees here, hypotenuse 100 meters, and this angle is known, it's given. Where it is given? So watch here. Slope of this line is given as 3 by 4. So it is a tan inverse 3 by 4. That is 36.87 degrees. So this inclined surface makes 36.87 degrees with horizontal. So this angle is 36.87 degrees. So opposite side is 100 sin 36.87, that is 60. Adjacent side is 100 cos 36.87, that is 80. And now follow the procedure. Choose origin where motion starts. Write coordinates of point given or known in the path. So what are the coordinates of point B? Coordinates are horizontal vertical distances from origin. So vertical distance is 64 below origin, that's why negative. So negative y coordinate. And horizontal distance is 80, x coordinate is 80. Now we'll write equations of motion. Horizontal and vertical motion. So Vx is V0 cos theta 0. In this case, V0 is u and theta 0 is alpha. X is equal to V0 cos theta 0 into t. Vy is V0 sin theta 0 minus 9.8 t. And y is equal to V0 sin theta 0, in this case u sin alpha t minus 4.9 t squared. So these are regular equations of motion, horizontal and vertical equations of motion. After writing equations of, now of course here u and alpha both are unknown here, but otherwise value of g is known, so we have substituted and we have written these equations of motion. And now once you write equations of motion, which are the variables whose value at any particular instant given. So it's given in the problem that at t equal to 5 seconds, x is 80 and y is minus 64. At t equal to 5 seconds, x is 80 meters and y is minus 64 meters. And this information is going to help you to find u and alpha. So just put these values in corresponding equations. So by equation 2, x is 80. So I have substituted x, and t I have substituted 5 and I got u cos alpha. That is one equation with two unknowns, u and alpha. Then by equation 4, that is equation of y, and y is minus 64. So put in equation 4, minus 64 is equal to u sin alpha, t is 5. So I have substituted t 5 and y minus 64. So u sin alpha is 11.7. So equation 2 divided by equation 1, and you get tan alpha equal to 11.7 by 16, and therefore alpha equal to 36.18 degrees. So this is how we have found out alpha, that is angle of projection. Now put this value alpha in equation 1 or in equation 2, and you have found out u. U is 19.82 meters per second. So that is what we have found out. Determine his initial velocity, that is magnitude and direction, u and alpha. So we have solved the problem. Now I have given you solved problem. Read those solved problems on projectile motion so that you will not have any difficulty.